Hello, everyone. So let me show you something that a lot of people were actually asking after Confidence 2017, something that we called a massive network security monitoring at Mozilla. So let's start with a story, and throughout the presentation, there will be a lot of stories, kind of trying to illustrate everything this way. So on a bright, shiny day, something like this happened. And what you can see here is some internal systems tried to resolve a bunch of domain names, nothing special about it, but those domain names belong to a known command and control malware server. So I'm like, I'd really like to know why an internal system from a data center suddenly started resolving a known CNC server. And second thing, but has anyone actually connected to it? Because if you have been in the detection for a while, you know that threat intelligence can be good sometimes, but you will have a lot of false positives. So a given system can resolve a malicious domain name, but maybe nothing will connect in the future. So what we did, I pivoted quickly to our log aggregation system. And I asked some extra queries. I was like, OK, MozDev, OK, bro IDS, please tell me everything that you know about system connecting to this domain, resolving this domain. I don't want to only know if something resolved malicious domain name. I want to know if someone connected, and if they did, what happened. So as you can see, the detail level that we have here allowed us to say that not only the malicious domain name was resolved, but also the malicious server actually sent us an SSL certificate. And by the way, I do know that there are other certificates, and the proper name is X509 certificate, but I will just use an excuse and call it an SSL certificate because it's so much easier to pronounce. So we can see SSL connection took place, HTTP connection took place. So I pivoted over to the HTTP. You might see or you might not see what is at the bottom of the slide, but basically I was quickly able to locate that, first of all, the user agent. So the user agent for this connection is qBittorrent. I'd really like to know one of my internal systems presents itself as qBittorrent. And I can see the full URL to the actual BitTorrent tracker file. So it seems like someone was actually torrenting using the internal jump host as a proxy for whatever reasons. So the only thing left for me to do was to delegate it to end-user services. Why am I showing you a half of a story like this will become more clear in the couple next slides. So basically, after Confidence 2017, I got this feedback, OK, story, but we expected you to talk more about your network security monitoring, bro, suricata. So, be careful what you wish for. And that's me presenting IDS in 2018. And you would be like, that's kind of boring, because I already have mine. NG firewall powered by IPDS, consuming TTP, IOC, oh my God, who knows what else. All these super things that make you sell everything else. But I'm here to show you something else. I'm here to show you the most unusual approach to network detection that you might have ever seen. And it all starts with a story. In 2012, my boss told me, I got you some new servers. And I'm like, new servers? I don't know about you, but I can take some new servers, always. And he had this crazy idea. What if we could store metadata about literally every connection? I want every connection in every one of our networks, metadata about this connection to be saved to disk. I'm like, you are crazy. And by every connection, I mean if there was, for example, HTTP session to something, I want to see details about this HTTP session. I want to see the DNS resolution that took place before this connection took place. If that file was transferred, I want to see this file. If it was like an SSL connection, Yes, of course, I do want to see details of this SSL connection. I want to even store a copy of that certificate. So basically, it's creating like a time machine for everything that you have in your network. And by storing insane amount of data, insane amount of logging information, that's basically what I mean. Here is an example from showing a detailed level of the logs from, for example, SSL log that we have. So just imagine that for every SSL session in the internal network and from the internal network to the external network, we store this amount of information and much more. All of the metadata, you can pretty much reconstruct everything that happened here. My boss also told me that he wants to be able to write arbitrary detection logic. And let me just give you an example of this. Let's say two hosts talk to each other over SSL, and we are super paranoid about SSL. And my network security monitoring, what it does, it basically tries to chain the CA up to the root, trying to say, okay, do I know about that certificate that was used for this SSL connection? If it does not know about the CA, if it's the first time it saw those certificates, I want some kind of low-level alert to be investigated later. And we also want to be able to save some parts of the network traffic to disk. We have no way to save entire network traffic to disk, but let's say I have a Windows PE file, which can be like executable or a DLL, flowing over a plain text connection. That's unusual these days. I want to save this file to disk to have it analyzed later. And by analyzed, I mean I want to capture this file from the wire, save it to disk, and have something like Yara or VirusTotal to pick it up and ask, hey, what do you know about this PE file? Like automatically. If it knows something wrong, if it knows something bad about it, yeah, I'd like to get an alert on it. So the big idea, to recap this part, is network security monitoring, sniffing everything on the network layer, even in internal networks, storing metadata about everything, and writing any detection logic that you ever wanted. So that's what I heard from my boss, and I raised a number of concerns. Like, I was like, it's 2012, you cannot do it, everything is encrypted, it makes no sense, it's too much of a data. So I just put a stamp, cannot be done. And there's got to be a reason for the back of my laptop. This is the actual back of my laptop. It says question authority, and that's pretty much what my boss looks at throughout the entire day. But you know, if you have, sometimes you have like a great leader which can infect you with the idea that will not let you sleep at night. So there you go, fast forward to 2018. We have something that works, and let me show you why we decided to build a system like this. So, like I said, we want to be able to collect logs. So I decided if we want to record threat actors' activity, there is no way to do it without recording our own actions, without recording our own activity. Then you might be able to catch some parts of threat actor activity. We want to be able to match IOCs, and my IOCs are not only different, as you're going to see in a while, but they are in a very different and very strange places that you might never look for IOC. And I want to be able to detect TTP. Everyone is crazy about TTP right now. Every vendor sells a product for detecting tactics, tools, procedures of a threat actor. I want to do some of this detection also at the network layer. So if you have been in the security industry for a while, you saw the IDS in the 90s. And it was basically like intrusion detection system and like 25,000 of rules full of things you cannot really understand. And when I deployed something similar, I had like 100,000 false positives per day. I tuned it from this time, but it can still kind of show you that the early intrusion detection systems were just limited to consuming insane amount of rules, matching traffic against those rules. If something matches, raise an alert. NSM in 2018 is very different. It is no longer IDS, it is a collection of several IDS engines, and it is nothing else but a big event-driven engine. So if you are, for example, a Python programmer or a C programmer, you know that you can have this framework, kind of like here. Traffic flows into your network security monitoring system, and what it does, instead of having a number of hard-coded rules, it triggers a bunch of events, and it's up to you to write the code to handle those events. What you do handling those events, I don't know, up to you. Write your own alerting logic. And there are like thousands of events to intercept. So let me show you an example. Let's say the event HTTP header has been triggered, and I want to detect something like an open proxy in my network. We have huge proxies, people install various things, and I want to be able to say that someone started a new, let's say, squid server that I don't know about. So I look for a local system reaching out to the internet. This local system has somewhere in the HTTP session the X forwarded for header, and this system is not on my whitelist of known proxies. And I want to know about it. I will not show you the code because it's kind of interesting, but it's a couple lines of code, and you have a detection like this. Why we go to such a great extent and do something like network security monitoring as a code? Everything as a code right now. Your infrastructure is a code. Why not your network security monitoring? Well, we basically want to answer the most important question in the universe. The most important question in the universe for me is this question. So when a new APT report is published, that's basically what the Mozilla threat management team does. We dig into our logs and various kinds of logs. And I'm not trying to say it's only NSM that we use. We dig into various kinds of logs. How do you like the fox? So let's take a look at what the example threat hunting looks like. I don't have an example from the APT report, but what I do is an example from the abuse.ch. And if you use abuse.ch, you should keep using it. If you don't use abuse.ch, you probably start using it. What it is a database of, for example, fingerprints for the SSL traffic, things like SSL certificates for a known malware traffic, for a traffic to a known command and control servers. So I want to see if any of my systems actually connected to a malicious system described by this SSL blacklist. So what I do a simple query, and in this query, I look for a serial number in the SSL certificate. And unfortunately, what you can see, I have some hits here. So some of my internal systems actually connected to the known malicious server and downloaded something from it. I don't know what it was because it's over SSL, but at least I'm able to tell something like this happened. And if you take a look at this table, it basically, for every system that I have, it tells you something like a connection UID, it tells you what the destination server was, it gives you a lot of metadata. I can pivot from here to, for example, the SSL certificate, the actual SSL certificate that was downloaded from a remote server to tell if it is not a false positive. I compare this data against abuse.ch, it's a match. I know I have a true positive. I know who tried to connect to those hosts. And by pivoting through various kinds of logs, by pivoting through various kinds of metadata that I store about every connection in my network, I am able to confirm the infection this way. What I really like to do after I see something like suspicious communication from a given host, it is a really good idea to look for the further network activity from the host that you think it might be infected. If, let's say, your internal host downloaded something suspicious, you are like, I want to see what happened next. Maybe it connects to some other parts of the attacker's infrastructure. Maybe I will uncover something else. Nothing to see here because that's pretty much what I can show about this particular incident. But let me just tell you that by default, using an open source solution like Bro allowed us to analyze all of these protocols that you see here. And all of these protocols analyzers generate logs by default. So you just throw bro into your network, and you have all these protocols analyzed at the detailed level. And yes, there is like NTLM and Kerberos and whatnot. If you see a protocol that you'd like to have analyzed, it's not here, you can have your own analyzer very easily. And it's all port independent. If the traffic flows over not standard port, that's not the problem. And every piece of information is connected by UIDs. The way UID is calculated, it's a standard 5-tuple, IP source, destination, ports, whatever. This connection ID is preserved across various logs. And I will show you in a second how it works. The good news is that the Bro IDS and Suricata IDS and network vendors, they started to cooperate. So you will be able to pivot between logs from, let's say, Suricata detected something, you go to Bro, you have the same connection ID, you ask Bro what it detected, then you pivot to your Cisco appliance, your Juniper appliance, whatnot. So let's take an example. Let's take a look at an example. Let's say I want to see who downloaded some suspicious Windows PE file. Suspicious for me in this case means it's been not 64-bit. And I have a log because what Bro does by default, if it can see a Windows PE file, it analyzes this file, and right away you can see why I'm worried about a file like this. It's compatible with Windows 95, Windows NT 4.0, it has UPX headers, and it misses pretty much every hardening feature that is, or binary hardening feature that is out there. Many of malware samples look alike. So I want to know who downloaded this file and what happened next. So there you go. I can pivot from the PE log to HTTP log to whatnot to what else. And no, I will not spend next 10 minutes trying to go through this diagram. But the point here is to show that you catch some suspicious pieces of information, you can get some contextual information to raise your contextual awareness. So I started looking what Bro knows about this file, and Bro was like, hey, I saw this host downloading this file over HTTP GET. Okay, let's see what else do we have here. So I pivot to the HTTP log, and the HTTP log tells me the suspicious UPX file was downloaded from something called web page test. I don't know what is web page test, but at least I know who did what. And unfortunately, if you take a look at the URL that was also recorded by our system, it is a path to the nightly browser. So I learned two things. First of all, my system is not infected. Second, we pack some installers with UPX. I don't know why, but I will raise some objections internally. So the lesson learned here is, first of all, you can pivot through various kinds of logs in Bro to give you contextual information. Second, in Mozilla, detection is difficult because nothing is what it seems to be. And by the way, a quick look at the Samba protocol. If you have a Samba network, if you have an Active Directory network, what you are looking at is an actual Samba file open operation from a share in Active Directory network, showing you the host name, the domain, the full path to the file on the share, pretty much everything. You can pivot from here to actual connections. So that's kind of useful. This is a break, so I can actually drink something. But the quality of a Bro talk is closely related to the number of the pyramids in the presentation. So I decided to go like a full scale here. We have this internal joke in the Bro IDS community that every presentation has to feature at least one pyramid. So 2015, 2016, BroCon, which is a Bro conference, pretty much every presentation has a pyramid. So it was like 1 a.m. I was like, I cannot be any worse. And I started learning some Adobe tools. So that's as good as it gets. I'm an engineer. I spent 4 hours on it. And the point I am showing you is, first of all, to win the pyramid contest. And second, to show you that we use network security monitoring at every layer of detection. You know this pyramid. This is a pyramid of pain. And you can detect IP addresses, hash values, domain names pretty easily with everything. And the attacker can add a single byte to your file, and the hash changes, the IP can be changed very easily. But we also look for something that is wrong on the network layer. We might not yet know what is wrong. We want to be able to detect tools on the network layer. And you are like, how can you detect tools on the network layer? And I'm like, those Salesforce people from, this Salesforce, they actually run a giant Bro cluster. They were smart enough to notice something interesting. They were like, the SSL proposal, it's very unique. What if we took, when two systems start to communicate over SSL, the client sends the SSL handshake telling, okay, these are things that I support. These are the protocols I can talk to you over. And a number of information sent by the client is very unique. So what they do is they calculate MD5 hash. And they have a unique fingerprint per app. And it's so cool, I cannot even begin to describe it. So basically, if you know your network well, you might whitelist every known fingerprint and alert or anything else. That's what some people do in the industrial control networks. In the industrial control networks, you should be able to know every fingerprint of application that you have inside. And then you alert on something that has never been in there before. Or maybe you want to, like me, you don't know everything, but you want to hunt for unusual fingerprints. So you are like, I have like millions of these fingerprints, but I have only 10 fingerprints coming from like 3 systems for something I don't know what it is. You might take a closer look at those systems. So there is a reason my friends look at me like this, and they think that's basically what my day of work looks like. Switching quickly to the IOC part of the presentation. The hunt for IOC. So when you think IOC, you think like IP source, IP destination, maybe some domain name, but we have some very unusual IOCs. I want to be able to match MAC address, the URL. I want to be able to match some file hash, or maybe a certificate serial number, or maybe another hash, or maybe I want to match everything that was issued by some particular CA, and this CA got compromised. I want to be able to match on other fields in the SSL certificate because everything goes over SSL. Maybe I want to match on every SSL certificate that was issued past or before some date. Or maybe even the user agent used. And not only my IOCs are very strange, I want to look for IOCs in a very strange places. If you think Intel domain, the standard and classic way to match a DNS name is in the DNS logs. But I want to look for DNS name in the SSL certificate, the server name that was requested, the HTTP host header, and basically everywhere when the domain name can exist. Same thing for IP address. We sniff traffic between backend and load balancers, and this traffic has a source IP of the load balancers, obviously. So the true client IP is hidden in some custom HTTP header. So what I did with like 5 lines of code, I implemented a client IP header matching against the intelligence framework so I can match there. If matching a single IOC is not enough for you, you can totally do something like a combined IOCs, and let's say, and every CA has been compromised. You want to match every single certificate past the compromise or previous or whatever. You can combine things. If you want to deploy many of these functionalities with some vendors, they are happy to deploy it for you if you send enough cache. I might not have enough cache around because I just load a single text file with enough code, and yeah. So that's just an example of a log file. Here we merged malicious domain inside of the SSL certificate. And here we merged client source IP in the custom HTTP header that does not exist probably anywhere outside of Mozilla. And I got a question for you. When do you think matching IOCs is most important? So matching IOCs for us is most important during the incident response, because you are doing something like this. You detect some compromised asset, and this asset has a backdoor on it. You take it, and this backdoor, for example, communicates with a CNC server on the internet. You take this IP of the CNC server, you deploy it back into the NSM, and the NSM in 5 minutes later is like, hey, I found some more hosts talking to the CNC server. How are we doing on time? How are we doing on time? Okay. Okay. Some other questions that we like to ask. I like to analyze like a backdoor traffic as well. And the last thing that I really like to use the NSM for is to prove some people wrong. Someone told me that it's impossible to sniff and correctly reassemble the traffic between load balancers and the backend if the load balancer does HTTP multiplexing. So first of all, do not ever tell me something is impossible, because I will spend a lot of time on it. And second, unfortunately, I had to spend no time on it, because everything is supported out of the box. Some other things that we do. I want to know when internal system started scanning internet. If the internet is scanning us, that's true for every one of you. But I want to know when one of my systems suddenly started scanning my network. Why? And the other thing that I really like is to use NSM for the vulnerability management. We do the traditional vulnerability management, but sometimes we don't have enough visibility. So when our operations team ask me, hey, do we run this protocol? Do we run this application? I'm asked, you are asking me? And second, excellent choice, because we probably know about it. So when something like Poodle attack happened and you had to disable SSL3 or you had to disable RC4, our management wanted to know what will fail, what parts of clients will be impacted and will not be able to connect to us anymore, because we just cannot fail. So we have to switch over every server that was using SSL to something else. So if a simple query like this, so if with a simple query like this, we were able to discover every system using SSL3. We also use it to kind of look at the appliance compliance kind of thing. Sometimes you can do a traditional vulnerability scanning, sometimes you cannot, but I can see user agents coming out of the appliance. I can do some fingerprinting of the traffic. So in a scenario like this, what I do is I treat the appliance like a black box, and I try to learn something about the black box that I cannot log into. Let's say you were fighting with like the Poodle attack and you don't have the SSL3 protocol in your network anymore. Then some team buys an appliance, and this appliance vendor does not care about the security at all. They deploy this appliance, and this appliance speaks SSL version 3. If you don't have monitoring on the network layer, you would probably miss something like this after a year or so, so I like to keep this detection in place. Or maybe this appliance does not have, does not produce any kind of useful logging data. Well, at least I can observe the network traffic to the appliance and tell something about it. If you remember the Heartbleed attack, we were changing every single private key, every single secret, every single public key, whatever, everything. Just to be paranoid, we changed every single SSL certificate and every single private key out there. Even not having been compromised. We are not compromised by the Heartbleed attack, but we changed everything just in case. So I wrote this detection logic, so my network security monitoring would tell me about all the C8 certificates not yet being changed, so we could catch them one by one. And after a while, NSM was like, I saw you changing this SSL certificate here and here, but you forgot about all of these servers. Some other questions that we ask is, it's one thing to detect like an old Java at the office. It is completely different thing to see old Java user agent talking to someone who is on the IOC list. And it is yet another thing to see this same host with old Java talking to a known malicious server, fetch an executable later. That is interesting. I want to know about it. Some other questions we ask is, why is this SMB protocol leaving my network? Or when you remember the recent attacks and the ransomware, why is the SMB protocol entering my network? I don't want any SMB crossing my network. Same thing about MySQL. I don't want MySQL to cross my network boundary unencrypted. Bro is, by the way, very efficient MySQL replicator. You just sniff the MySQL network traffic, and you can create a copy of a network database. Network copy of a database, like entire database. You should be careful with some kind of logs. Or why are our iPads leaving our office? I mean, like physically leaving our office. So we have a bunch of iPads at conference rooms for managing the audio-video equipment, and we had like a physical breach into one of our offices. It does not hold any secrets, so stay put. But this office had a bunch of iPads stolen by someone who wanted to sell it on a black market, and for some reasons, the CCTV was broken. So we didn't really know when the actual event took place. So my manager, he was like, you know, I have this idea. I know when this happened. I got these informations from Bro, but how? And he was like, because all of these iPads were beaconing to Apple servers. And at some point, they stopped. Okay, that's when the iPads were probably taken. We also detect a lot of protocol anomalies. I want to know whenever on port 80, something is not HTTP, or I want to know about SSL on some unknown ports or some unusual ports other than 443. A couple of things like this. This is the anomaly detection part on the pyramid of pain, basically. We even watch our vendors, so we use Gmail. So we have a bunch of rules looking for certificates that pretend to be Gmail, issued by some, even a trusted CA, but it is not a Google CA. So kind of, and some of our employees, if this employee would actually click on a link leading to a phishing site presenting an SSL certificate with a fake Google CA, I want to know about it, and Google wants to know about it. I literally like send them information about it. And I could like go on and on and on and on. I have a bunch of things that we check on the network layer. We are paranoid about the cyber suits, parameters, SSL keys. I don't want any base 64 authentication. Those are all the things that we check on the network layer as well. You don't have to write your own scripts. That's the most important part. You just deploy most of the scripts for something called the Bro Packet Manager. And it contains a bunch of scripts written by people way smarter than me. Like, for example, these people from Corelight. This is kind of like a DLP functionality. Long connections or bursting connections. A very short but high-speed connection that sends something somewhere. Maybe I want to know about beaconing like this. So to summarize this part, we are minimizing our attack surface from 2012. And no, this is not yet the end. You're looking at it and you're like, it will not work in our network. Because you have network which has like 100 gigs per second. You are thinking about like capture cards, hardware, acceleration, whatnot. Well, let me tell you that we do it on a bunch of fairly beefy servers, expensive servers, but nothing special about them. Generic Linux installation, generic Linux kernel, AF packet, for those of you that know AF packet, it was a source of all kinds of problems in the past. Right now, the AF packet is amazing, and the AF packet team actually knows about those use cases. And we were able to speed up Suricata, not Bro, Suricata. to 40 gigs per second on a generic hardware, generic network card which costs like $400. If you want to know more, slides will be published and there will be links to a research about this. One of the last things I'd like to present is, I told you that we sniff a lot of network traffic, so that's basically what we do. You can see that we sniff network traffic not only between border of our network and the internet, which is the traditional way to do it, we sniff traffic in our internal network. So when a host from VLAN A talks to a host from VLAN B, we sniff this traffic as well. Every single time a host crosses a VLAN, we sniff this traffic. For offices, we even sniff some internal traffic not leaving the VLAN, going like, for example, all hosts on the same level. And we do it over 3 continents, 9 offices. We do it also in AWS. And we send 10,000 events per second to our system to store metadata about connections. Nothing special about how we store those logs. It's like a generic logging pipeline. Logs are written to disk. Where is my disk? Here. Logs are actually being picked up by the syslog-ng. Those are JSON native files, but there are a number of possibilities of what you can extract from Bro. Kafka is supported, streaming JSON without writing is supported, and Elasticsearch is supported, but we use syslog-ng, send things over AMQP to Mosdev, and syslog-ng on my host, sending 10,000 events, has like 4% of the CPU usage and like 200 megabytes usage memory. So whatever, it works. We use Clear Linux. We used to be using Ubuntu. We switched to Clear Linux. And we use fairly generic Intel hardware. What else? If you wanted to start with something like this, the learning curve can be very steep. It can be difficult to do it. So I would recommend starting with something like a security onion, or even going to the webpage trybro.org. It is a webpage that lets you upload some pickups. You don't have to do anything else. You take a pickup, you upload to this webpage, and you see what kind of logs will be generated for you. Even an exercise like this can be kind of enlightening. If you don't want to upload some sensitive pickup to this webpage, no problem. You can actually fetch an entire Docker image and deploy this trybro.org in a Docker and write it locally, write it in a sandbox, and use it as yet another tool in your sandbox. On the trybro.org, there is actually a step-by-step tutorial written by someone who had this assumption that this tutorial is written for people who never experienced this kind of language. And there are a bunch of like other materials as well. So with this, I'd like to proceed to the QA if we still have time. Okay, I will be taking questions in any language, Polish, English. I will translate if necessary.
Thanks. I have many questions, but I'll try to limit myself to 3 only. So you mentioned, so first one is how big your traffic is, like every day you have to handle?
Yeah, so right now we handle up to 60 gigabits of traffic with 8 Bro servers and 2 Suricata servers.
Okay, so for how long do you keep your logs?
We keep our logs for 90 days.
Okay, fair enough. How do you handle domain fronting?
How do you handle what?
Domain fronting. So the attack, the CTO is utilizing some third party which is trusted.
So there are 2 answers to it. We do not allow domain fronting on our side, so we are not used as the domain front end to connect to someone else. But on the client side, if someone uses a domain fronting from Google, starting connections from our network, we will be blind. There is nothing we can do about it.
Hello, I have a question regarding general data protection right. What was the effort for you to deal with the GDPR rules, and just about how much time did you spend? What was the effort to deal with this?
So the effort was insane, and it took me several years to build everything from scratch. This is not the case anymore. Throughout the exercise of building this system, we uncovered a bunch of performance issues and scalability issues in Bro. So we were like uncovering something, Bro was fixing it, giving us a patch, we were testing it, and it was going back to Bro. So that's why it took so long.
And more about some legal issues?
Some of the issues were it could not handle this much traffic without dropping the traffic, and other issues were some of the scripts will actually kill Bro. So I have this example when I was trying to keep a state for every client that connected to us and do a modeling. For example, for every client, I want to know the ratio between the good requests and the bad requests. And if the connection is all the bad requests, I want an alert. I was trying to keep a state for every client that connected to us, and with 400 million of Firefox users, it was just crashing.
Got a question about this event generating system that you mentioned at the beginning. Is it part of MozDev or it's something else? And
So
if
this
it's something else, are you going to open source it?
So this event generation system is part of the Bro IDS.
What sort of GUI are you using? Your internally developed one or some commercial or open source?
We use for this project only open source tools, open source solutions, so the entire project is 100% open source at the cost of my time and at the cost of a couple months of work. But there are some commercial solutions for it. If you just want to deploy Bro, there are companies happy to help you with it, so you don't have to go for it. Okay, I don't see any more questions. If you have some more questions, I will be here for like the full 2 days. Feel free to approach me and ask me pretty much any question about it. I might even tell you a little bit more than I was able to tell from the stage. Thank you.